This is Math 8, Section 1.1, Exponential Notation. Our lesson objectives are to understand and use exponential notation, and to use exponents to write the prime factorization of a number. Let's first understand exponential notation. Exponential notation is a way of writing things easier than they are written when they are in their longest form. For example, 1 billion would be written with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. If we want to write it as smaller, first we need to convert it into its factors. So to get 1 billion, we can multiply 10 times itself. 1, 2, 3, 4, 5, 6, 7, 8, 9 times for as many zeros as there are. If you're not sure, just check your calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 tens. This could also be written as 10 to the power of 9 because when you multiply something times itself, you put as your exponent the number of times that it appears. Therefore, we have 10 to the power of 9. 10 in this case is your base. 9 is your exponent. The base will come from the repeated number, and your exponent will come from how many times it is repeated. How many repetitions? So as you can see, we go all the way out here. Our number is 10, that becomes our base. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is our exponent. Okay. Next, let's try an example. So, I'll put a star. Example 1, let's try it together. Identify the base and the exponent in each expression. A is 1.26. 1.2 to the power of 6th. In this expression, 1.2 is the number on the bottom. That equals the base. 6 equals the exponent because it is on the top. In this case, base is the repeated number. Exponent is the 6. If we were to write this out as above, it would look like this. 1.2 times 1.2 times 1.2 times 1.2 times 1.2. 1, 2, 3, 4, 5. 1.2 6 times because we repeat it. 1, 2, 3, 4, 5, 6 times. Therefore, 1.2 is our base and 6 is our exponent. Let's try example part B. It is negative 4 in parentheses to the power of 5. And here, the base is going to equal what's the big number. Base and big both start with B. That's how I remember it. So negative 4 equals the base, and 5 equals the exponent. If you wanted to write it out like here, we would do negative 4 times negative 4 times negative 4 times negative 4 times negative 4. This isn't necessary to write out every time, but if you would like to multiply it out to check your math, this is how you would do it. This is example 1. Go ahead and pause the video and try guided practice 1 and 2. Guided practice 1 and 2 we will go over in class. Let's try example 2. Tell whether each statement is correct. If it is incorrect, state the reason. A, our statement is 2 times 2 times 2 equals 6, 2. You'll notice instead of an X, I put dots. That is how the multiplication symbol is represented. So instead of putting the times, we will begin using dots for multiplication. 2 times 2 times 2. So let's find our base. The base is the repeated number, therefore base is 2. It's repeated 1, 2, 3 times, therefore exponent equals 3. Here our base is 6 and our exponent is 2, therefore these do not match, and this would be an incorrect statement for that reason. This is the reason. Now let's move on to B. For example B, example 2b, it says 23 to the power of 4 equals 23 times 23 times 23 times 23. Let's find the base. It is, in this case, 23, and that is also our base here. And the exponent is the repeated times, 1, 2, 3, 4. The number here is 4. Therefore, it is correct. Part of example 2. Go ahead and pause the video and try guided practice 3 and 4. Moving on to example 3, write in exponential notation. What they give us for A is 5 times 5 times 5. The solution is going to be okay, 5 times 5 times 5 times 5, and we will first find the base, which equals the number that is being repeated, that is 5. Then find the exponent, the number of times it's repeated, 1, 2, 3, 4. The exponent equals 4. To write in exponential notation, we'd write 5 as our base, exponent of 4. Moving on to B. We have -3 times -3 times -3 times -3 times -3. In this case, our base equals -3. Our exponent equals the number of times it's repeated, 1, 2, 3, 4, 5. Our exponent is 5. To write it in scientific notation, we would write the -3 below and the 5 as our exponent up top. And that is the answer to B. C. Our problem is 1/2 x times 1/2 x times 1/2 x our base equals 1/2 x, exponent equals 3. Therefore, in exponential notation, that gives us 1/2 x with the exponent of 3. And that is example 3. Go ahead and pause the video and do guided practice 5, 6, and 7. Okay, moving on to example 4. In example 4, it says to expand and evaluate each expression. Let's start with A, 2.5 to the power of 3. How we expand this is we write our base, 2.5, and it says how many times in our exponent, how many times we should repeat it. So we put 2.5 3 times. 1, 2, 3. If I put those in my calculator, 2.5 times 2.5 times 2.5, that gives me 15.625. Let's try B. B is -4 to the power of 2. This expanded is our base of -4. It needs to be repeated 2 times because that's our exponent. If we multiply -4 and -4, it gives us positive 16. For C, we have 2/3 to the power of 5. Now for this one, I need to write 2/3, the base, 5 times. 2/3 times 2/3 times 2/3 times 2/3 times 2/3. To multiply, I multiply the tops of all of the 2's, which gives me 32, and all of the bottoms, which gives me 243, and that is the answer for C. Just a note, you cannot write, I'll put this in a box, -4, 2. You can, okay, -4 squared equals 4 squared. The book asks, why or why not can you write it like this? You can write it like this because -4 squared is going to be -4 times -4, and 4 squared is 4 times 4. -4 times -4 is 16, and 4 times 4 is 16. Go ahead and pause the video and do guided practice 8, 9, and 10. That is the end of this video for this portion of 1.1. Be sure to rewind to go back to any parts you did not understand and consult your book for the guided practice problems.